Okay, another problem. Okay, this problem says that a stationary block explodes into two pieces, L and R. So first you have some explosion. And what equation can be used for explosion?
Conservation of momentum.
Conservation of the momentum, okay. Of course, you don't have any energy relationship for the explosion. You can think about explosion. You acquire huge energy, okay. So you don't have energy relationship. So the energy is not conserved. And so it explodes into two pieces, air, of course, air and left and right, so air and R. That slides across a frictionless floor, and then into regions with friction. Okay, so the explosion happens for a friction and frictionless situation, and then they move into a region with frictional force. That's kind of to simplify our problem, so we can separate them into different parts. Where they stopped, okay, piece L, so it's something like this. First you have a big block, like this, and then it breaks into two pieces. So of course one piece will move to the left, another will move to the right, okay, and then so they start to go to some frictional surface. So finally it stops here. This one stops here. Okay. So you can think about there are some processes we need to consider. First, there is the explosion process. Okay. And then this one undergoes a stopping process due to the friction. Another one undergoes stopping process due to the friction. Okay. So we need to analyze this process. And what we know is that the left piece mass is 2 kilograms. Let's call it ML equals to 2 kilograms. And how about the right piece?
3.
3, okay. FR equals to 3 kilograms. And for the two different frictional surfaces, they have different coefficient of kinetic friction, okay. So let's call this is mu k L equals to 0.4. And here mu kr equals to 0.5. And of course, they may have different stopping distance. Okay. So for the left piece, the stopping distance is like the distance of 0.1 meter. So the stopping distance we call dl, okay, equals to 0.1 meter from here to here. And the stopping distance for the right piece, dr, that's the quantity we want to find. Okay? So that's what happened here. Now let's look at this. So if we we have 3 processes we need to consider. So for explosion, right? And then for the slowing down and stopping of the left piece. So piece L, okay, and piece R, the motion of piece R. Okay, now we can see that for the explosion, of course, we are going to use momentum conservation. For piece L and piece R, what equation should be used? Okay, some slowing down process usually mean total energy conservation because they have frictional force. So it cannot be the mechanical energy conservation, right?
Delta E equals WNC.
So delta E equals to WNC, total energy conservation. Okay? If you don't have frictional force, the mechanical energy should be conserved. If you have frictional force, the mechanical energy delta E equals to the work done by frictional force. You use that. So the explosion process. First, let's look at the momentum conservation. So, what is the initial momentum? 0, right? Okay, initially you have a block stay there, the momentum is 0. And then, bang, after collision, both of them acquire some velocity. So, the final momentum is the momentum of left piece plus the momentum of right piece. Right? So it's M, L, V, L. Okay, so let's put this is V, L. It has some velocity. And V, R. Plus M, L, V, R. Okay? Oh, MR. Okay? Now, for the piece L, it moves with some velocity VL after the collision. And finally, it stops here. And so to use the mechanical energy conservation, delta E equals to WNC. Okay? So in this case, so we have K final plus U final minus K initial plus U initial equals to, in this case, the only work done by the non-conservative force would be the work done by the frictional force, right? WF. Similar to that stopping process. So, according to this equation, let's write down all the terms. What is the final kinetic energy?
0.
0. What is U and U naught?
0.
Both of them will be 0, right? Horizontal motion. You don't have the gravitational potential energy change. So finally you get negative K naught, so you get negative K naught equals to WF. Similar to that. So for this one, it should be negative 1/2 ML VL squared equals to WF. Okay, again, here we just choose that WF should be this, right? Okay, the frictional force, the same analysis. So negative mu KL M L G D L. That's for the left piece. Okay. Any question here? Now for the right piece, similar equation, as we just read to, is just MR VR squared equals to negative mu KR MR G DR. Okay. Same kind of situation applied for both piece L and piece R. Any question for these equations? So that finished most of the part of the problem once you write down these equations correctly. And then you can see once you write down these equations, you can analyze. We try to find dr, right? So basically, you can see what we need. If we want to find dr, we want to know Vr, the velocity of the block R acquired after the explosion. And how can we get Vr? We can go to this one. So if we want to find Vr, we need know VL. Okay, due to the momentum conservation, if you want to know the velocity of this block, you have to know the velocity of this block. And how can we know the velocity of the left piece? Because here we give you dl. Okay. The traveling distance for the left piece. So from this one, you can solve for VL. So basically the idea is that you know dl, you calculate VL, then you calculate dr, and then you calculate dr. Okay. So you first use this equation. Okay, so that's the idea. You can first use this equation, find out VL, and then use this equation to find out VR, and then you go to this equation to find out DR. Right? So that's a general process. But here, you can use a little bit math trick to simplify the calculation. You can do it step by step. This is first step, second step, and the third step. Okay. But you can try to use a little bit trick to simplify. So you can write this equation as, okay, negative ML VL equals to MR VR. Right? And then this equation and this equation actually can be simplified. This equation says that so ML, let's simplify this equation here. So you get 1/2 ML VL squared equals to mu KL ML GDL. And ML cancels ML, okay? So you get VL squared equals to 2 mu KL GDL, right? Okay? So VL equals to square root of 2 mu KL GDL. Okay. And the same kind of simplification, of course, applies to another piece. So you can immediately write VR equals square root of 2 mu KR G dr. Okay. And now, if I put this VL and VR into this equation, okay, so the calculation will be much simpler. Negative ML multiplied by square root of 2 mu K G dl equals to MR multiplied by square root of 2 mu K G, mu K, this is L, this is R, G dr. And then, what you can do is you write this, you put this to the left hand side, so divide both sides by, we want to put ML to this side and put this to this side. So I get square root of 2 mu KL GDL divided by, you have negative side here, square root of 2 mu KR GDR equals to MR divided by ML. Right? And then this is negative square root of 2 mu KL GDL divided by 2 mu KR GDR equals to MR divided by ML. So, what's wrong?
It's just a long process.
just standard algebraic manipulation. Okay, so for this part of, okay, you need, so if you feel more comfortable with this algebraic manipulation, then you can focus more on the physics part, so it's easier for your test. So math is very important for us. Question?
Why'd you factor out the mass?
Hmm?
Why'd you factor?
Okay, here I say that the reason I do this is basically I'm trying to, you can do it step by step. First solve this equation, solve this equation, solve this.
On the second one?
Second one?
Yeah, why did you factor out the mass instead of leaving it in the square root? Why does that change the formula?
Okay, you can, so what I'm doing is, okay, first I divide this by ML,
okay.
right? So I make ML here.
Okay.
And then when I divide both sides by this, I get this here. The reason is I want to cancel many of the quantities, so the final calculation is very simple. Because here you can see, right? So you get equation like this. Negative square root of mu k dl divided by mu k or mu k l, mu k r dr equals to m r over m l. So you want to solve for dr. So it's just one equation stuff. Okay, so that's very simple. You know all these quantities, and you can solve it with dr. It's just even this is a common way to solve some of the equation. In many cases, we try to solve several equations. You don't have to do it step by step. You can try to put them together. Okay, it simplifies the calculation. Especially when you realize that this equation looks very similar to this equation. So if you put them into this equation, probably can cancel a lot of quantities. Okay, that's why I use this way to solve the equations. Okay, so. But basically, this math, you need to do it by yourself. This is not about understand it or not. It's about can you really do it during the test.